Hello, I'm Mark Thompson from Paxton Access. I'm the development director here, so my responsibilities include looking after our product development activities. I'd like to show you our workshop. This is a new facility that we've come up with to develop prototype models of new products, to endurance test products, and to design and manufacture test jigs for our products. So come with me. This piece of equipment we call the TARDIS for obvious reasons. This unit has 220 of our new Net2 Plus access control units, and we use the TARDIS for testing new versions of software, and we've used it to prove the product before releasing it to the market. So each Net2 Plus control unit is connected via an RJ45 Cat5 patch lead to a switch. So what I can do is pull out a tray and show you the control units on the tray here. As an example of the kind of things we might do, a very simple operation, we can open all the doors on these 220 units at one time. So Chris, would you like to open all the doors? This is our EasyProx endurance test jig. Here we're testing 10 EasyProx units and taking them through 250,000 cycles. So you can see here this unit, there's an eccentric cam here. This is of our own design with holes in it to provide equal weight or equal mass around a centre point to reduce the strain on the motor. So this cycles through, taking each of these units through a test sequence of locked and unlocked. All the information, all the status information, it goes back to a central unit here, which then wirelessly talks to an Ethernet bridge. We can view this through a web server to see remotely, to see what's going on, to see how many cycles have been completed, whether there have been any failures, how many times the latch has fired. So this is all homegrown, and it's used for ensuring new products are fit for market and for testing production batch samples.
So we have a milling machine for making parts that we can use in real-world applications, testing and prototyping. We can also do PCBs, which allows us to, again, prototype and make jigs up for testing our products. It's really concentrating on taking what we do on our state-of-the-art CAD systems and producing realistic functional models.
This is one of the many machines we have in our workshop, and each machine is controlled via one of our plastic ACU housings. In here we have a Net2 Nano talking to a bridge over there. The Net2 Nano relay outputs are connected to a contactor which controls the power to the machine. On the front of the cabinet is an energy-saving reader connected to the Net2 Nano unit. This enables us to control access to the machine, so only users with the right credentials, those that have done the health and safety and have been trained on the machine, can use the machine. So if I, for example, plug my card in, then we see a red LED. That indicates I can't use the machine and stops me powering the machine. Now if Mark comes and puts his card in, he's allowed access, so he can now power the machine up and use it.
Here we're performing a test schedule on the EasyProx Nano. This you see in front of you is our environment chamber, which tests our products to the extreme operating temperatures. With this particular product, we're going for 0 to plus 55 degrees. Currently we're around about the 0 mark. And as you can see, he's fine. And over here we have a small to medium-sized system of EasyProx Nanos that are being tested for communications, stability and reliability, and I'll show you those now. Here we have a 16-door system, and you can see each one is set up for a door open time of approximately 3 seconds. And this is to ensure that each unit will read at an adequate read range and that the units will communicate back to the Net2 server en masse.